Namaskar. Myself Dr. Ashwini Kumar Gupta. Today we will be starting with our lecture series 8 for basic organic chemistry. As you remember in the previous lecture 7, we had done some basic rules how to first give naming to the aromatic compounds and then followed by isomerism, in which I had told you there are different types of isomerism like structural isomerism, stereoisomerism. Then in stereoisomerism you have configurational conformation. Then in structural you have chain, position, functional, then tautomerism, then ring chain isomerism. Okay? Of the different examples of structural isomerism, we had done chain isomerism and functional isomerism. Chain isomerism and functional isomerism. Yeah. And I had explained you what do you mean by chain isomerism, and also I had explained you about positional isomerism. Now, today we will continue with our positional and many examples also of positional isomerism I had given you. Today we will take one example of an positional isomerism which shows both chain as well as positional isomerism. Chain as, because here I want to introduce a new concept now. Chain as well as positional isomerism. Take for example, we will take an example of say 6. That means C, 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 6, right? It's understood. It's understood. CS. Every time I will not write it. CS3, CS. Just once I am writing it. 3, CS2, CS2, CS2 and CH3. Okay. 3, 3, 6, those 6, 6, 6, 12. C6H12. Right? Extremely sorry, C6H14, right? So every time I'll not write CS3, I'll just write it. So suppose if I take this happens to be N-hexane. Now second, 1, 2, 3, 4, 5, 4, 5, and here 1, 6. Means at the second position I have a 1, 2, 3, 4, 5, right? Now this 1, 2, 3, 4. Here the second, right? Now this is at the second position methyl. That means this is 2 methyl. That means I can say this is iso, because 2 methyl is iso, if you know. Now, and this happens to be something 3 methyl. This is 2 methyl, this is 3 methyl. Then 4 happens to be 1, 2, 3, 4. C and C. Right? This is also 6. So it will be 2, 3 dimethyl. And this is the fifth one, happens to be C, 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 C. 1, 2, 3, 4, 5, and one more 6. This is to 1 carbon atom and 3 carbon atom are directly attached, so it is neo. Right? Now, so for C6H14 there are 5 isomers. Now if I see 1 and 2, 1 and 2. There is a difference in chain. Here there is 3, 3, 6. There is 3, 2, 5. Means there is a difference in chain. So they are known as chain isomer. Look to my previous lecture where I have told you what do you mean by chain isomers. I have told you that same molecular formula but different structural formula. I mean different properties due to the different number of carbon atoms. Different number of carbon atoms in the chain. Here there are 6 carbon atoms, here there are 5 carbon. So they both will show chain isomerism. Then 2 and 3. 2 and 3. Here the number of carbon atom remains same in 2 and 3, but only the branch changes, so they are 2 and 3 are nothing else but positional isomerism. They show positional isomerism. Now I will see 1 and 3. 1 and 3, they will show chain isomerism. One and 3 will show chain isomerism, right? Then we will see 2 and 4. 2 and 4. 2 is 3 and 4. Then 2 or 4 also shows chain isomerism. Then 4, 1, 2, 3, 4, 1, 2, 3, 4. Then 4 and 5. 4 and 5 will show positional isomerism. Right? 4 and 5. Positional isomerism, because they have the same carbon atoms but the branches is different. Right? They have different carbon atom in the chain. So a same compound C6H14 but shows 1, 2, 3. So many, it shows both chain isomerism and position. So whenever you get such a compound in which it shows a series of, it shows more than one isomers, then that time what happens? The priority order of the structure with respect to isomerism is, first comes ring chain isomerism, then comes tautomerism, then comes functional isomerism, then comes metamerism, then comes chain isomerism, and then comes positional isomerism. So from here to here we have to go, right? If a compound shows more than one isomerism, then who is the most preferred? Here it shows chain and positional. So I can say C6H14 shows both chain and position, of which it is known as a chain isomerism, because as per order, the priority order, the C comes first, so it shows a chain isomerism. Similarly, in the further cases we will see the one compound which shows many more isomerism. So accordingly we will have to take a note of this. This is very important. RTFMCP: ring isomerism, tautomerism, functional isomerism, metamerism, chain isomerism, this positional isomerism. Fine. Okay. Now I think so we have finished lot of chain isomerisms, functional isomerism. Now we will do with something in the now. After this we will go for functional isomerism. Functional isomerism. Functional isomerism. Now what do you mean by functional isomerism? As usual, compounds having same molecular formula but differ in properties, due to the presence of different functional group. Right? Same molecular formula but differ in the properties due to the presence of different functional group. Take for example CH3, CH2, CHO, that is propanal. Similarly, it can also be written as CS3, CO, CH3, which is known as propanone. This is propanone, NON, and this is propanal. You see the molecular formula of both the compounds are same, but their functional group has changed. Here it's aldehyde and here there is a ketone. Right. Now similarly we will see another example. CH3 CH2 COOH and CH3 COOCH3. Here there is the acid and here there is an ester. Here there is a, this is known as methyl because O directly bonded to methyl, CH3, so methyl has to be written as first methyl, then 2 it is bonded to methyl ethanoate. This is methyl ethanoate and this is propanoic acid. Propanoic acid. Fine. Now similarly we can take one more example. CH3 CH2 dash C triple bond CH. Right. Now this also can be written as CH2 double bond CH dash CH double bond CH2. See 3 to 5 and 1 6. So this is 1 2 3 4 C4H6. This is 1 2 3 4 2 2 4 5 6. See this also C4H6. This also C4H6. This is known as but 1 YNE because it is triple bond, and this is buta 1,3 diene. Fine. Now another example we will take CH3 CH2 double bond CH dash CH2 OH. This is the allylic carbon atom, so it is known as allyl alcohol. It is a primary alcohol. It's a primary alcohol. Similarly, we can take this as CH3 CH2 CH2 CHO. This is propionaldehyde. Right. Similarly, it can also be written as CH3 CO CH3 because if aldehyde comes into picture means understood सी बात है, because if you see 1 2 3 4 1 2 3 4 sorry 1 2 3 C3H4 5 6 O 1 2 3 3 2 5 and 1 6 O. Here so 3 3 6 C2H6 C3H6O, right? So allyl alcohol, propionaldehyde and acetone, these are positional isomers, same molecular formula but the functional group is changing. OH, aldehyde and ketone. Fine. We'll see some more example. Take for example now this is C6H5 CH2OH. This is known as benzyl alcohol. Benzyl alcohol can also be OH CH3. So see here it is 2 and 1 3 O H3O. Here also right, here also CH2 becomes CH3 and their OH goes here, right? So it is C6 7 C7H 1 2 3 4 5 6 7 8. Oh, this happens to be C6 and 1 7 H 1 2 3 4 4 and 3 7 and 1 8 C7H8 and O. Fine. So this becomes, you can say, as we know, it's orthocresol. Orthocresol. And this is benzyl alcohol. This is benzyl alcohol. This is benzyl alcohol and orthocresol. Right? Now, last example I'll take. Now, so many examples I have done. CH3, CH2, CH2, NH2. This is nothing else but a primary amine. It's a primary amine. Now, suppose CH3, CH, you can say NH and then CH2 and then CH3, 3, 6, 7, 8 and 9, 3, 3, 2, 4, 6 and 3, 9, right? C4H9, C4H9N, right? So this is a secondary amine. This is a secondary amine. And similarly, CH3 and CH3, CH3, this is a tertiary amine. So primary amine, secondary amine and tertiary amine, right? Primary amine, secondary amine and tertiary amine. C3H32 for 4, 3, 7, 7 and 2, 9. 3, 3, 6, 7, 6 and 2, 8 and 1, 9. 3, 6, 3, 9. Right? So primary, secondary and tertiary. Right? Now just make a look at it. I will, now I'll rub it. Fine? Okay? Now we'll go to the next topic. Metamerism. Now what do you mean by metamerism? Now metamerism is what? The same thing. Compounds having same molecular formula. Compounds having same molecular formula, but they differ in their properties. They have same molecular formula, but they differ in their properties. Why do they differ? Because they differ in the properties due to the arrangement of alkyl groups. Due to the arrangement of alkyl groups present across the carbon atoms of a particular functional group. Metamerism is what? Metamerism is nothing else but different, same molecular formula but different, showing different properties due to the arrangement of alkyl groups. Due to the arrangement of alkyl groups across the carbon bonds, across the carbon atoms, in having the same functional group. Having the same, the functional group is not going to change, but it will have the same functional group. Not name of any specific functional group I am saying, but a same functional group. Functional group in both the compounds will be the same, but only the arrangement of the alkyl groups along the carbon atom will be changed. I'll give you some examples. So how will I say? Same molecular formula, different properties. Why? Because difference in arrangement of alkyl groups present in them. You can say same thing, that is okay, metamers. Those two will be known as metamers, no? Metamers they differ only in alkyl groups present, but have same functional group. Just make it a note of it. Same functional group. The functional group will be the same. Only the arrangement of alkyl group is different. So those two compounds are known as metamers. Might be two or more than two. It's not compulsory to only two or more than two, as was in the case of functional isomerism. Now, we will take one example. Take for example C2H5O C2H5O. No. This is known as the ethoxy ethane. As we know, in the IUPAC we have seen the longest parent chain will be taken as the primary, but here ethane is here also, here is ethane. So this is the primary, and this is, suppose OCH3 is represented by alkoxy. So ethoxyethane. So ethoxyethane can also be written, and now the alkyl group we have to change it. Suppose we can write like that, C3H3O, CH2, CH2 and CH3. Fine. See, it was 224 and C4H10O. Here it is 3, 4, 3, 7 and 3, 10. And one more, C4H10, C4H10O. Here also C4H10. Fine. This is ethoxyethane. Now here the parent happens to be propane. So it will come in the last. And this is methoxy. So it will be methoxy. See, these are the IUPAC is coming everywhere. Methoxy propane. Propane, why? Because it is the longest carbon chain. That will be in the suffix. Methoxy propane. So these two are metamers of each other. Now this happens in case of ethers, right? Now we will take C2H5 and C2H5. This will say diethylamine. Diethylamine. This can also be written as CS3 NH. CH2, CH2, CH3. Same thing. 1, 2, 3, 4. H. 4, 4, 3, 7 and 3, 10 and 1, 11. Here 5, 5, 10. Oh, sorry. Here it has to be H diethylamine. So it will be C4H11 diethylamine. And this will be methyl. Propyl is the longest. So methyl propylamine. Methyl propylamine, right? Methyl propylamine. So these are, so even as I had told you, they have to be same functional group. Here there is an amine functional group. Here also it is an amine functional group. Here it is an ether. Here also it will be ether, right? So now I'll give you one more example. Take for example HC double bond O dash O CH2 CH2 CH3. Fine. Now we can say CH3 C double bond O O CH2 CH3. Take for 1, 2, 3, 4. C4H3 3, 6, 7, 8 8 O2. Here 3, 4, 3, 7 and 8 O. So H8 O2 we have seen, and 1, 2, 3, 4 C4. Fine. This will be known as, this is formate. So propyl formate, propyl formate. Now this is ethyl and this is acetate. O bonded to O will be written first, as we know. Ethyl acetate. Here propyl is bonded to O, so it is propyl formate. Ethyl is bonded, so ethyl acetate. Similarly, we will have to take CH3, CH2, COO, CH3. So this is C4H8O2. Fine. CS3, CS2, CO, CS3. So now this will be coming first. Methyl 1, 2, 3 propionate. Methyl propionate. So here ester is the functional group, right? I hope now you can see same functional group but different, same molecular formula but different properties due to the arrangement of alkyl groups along the carbon atoms, right? This then having the functional group has to be the same. Functional group has to be the same, right? So this is known as metamerism. Fine. Now we have taken many examples. I think so. It's very easy to remember. Now we'll go to some different topic now. Another type of isomerism is ring isomerism. Ring isomerism. Now what do you mean by ring isomerism? It's compound which are having same molecular formula but different properties because they have open chain and cyclic structure, right? Matlab functional group, compounds having the same functional group but they differ only by that one structure has an open chain and the other structure has a ring. So it is known as a ring isomerism. Take for example CH3 CH double bond CH2. Right? This is known as cyclopropane. This is propene. This is known as cyclopropane. Fine. 3 to 5 and 1 6, 2 4 6 and 3, right? Cyclopropane and propene, they both are same molecular formula, 3 to 5 and 6, C3H6. This also is C3 2 4 6, C3H6, right? Cyclopropane. Similarly we can see CH3 CH2 CH double bond CH2. Take for example this also happens to be but1 in. Fine, like that. This is known as cyclobutane. Similarly it can also be written as like that, CH3. Fine. This is C1 2 3 4 H 3 2 5 and 6 and 7 8. This is C4 2 4 6 8. This is C1 2 3 and 1 4, C4 H 2 4, year 1 5 and 6 7 8 6. Okay. So this is methyl cyclopropane, we can say methyl cyclopropane. Fine, this was cyclobutane. We'll take the last example in this case. Today I'll do a very short lecture, right? CH3 CH2 dash C triple bond CH. Take for example this is C4H224 and 37, right? This is but1 ion. Then see, take for example CH2 double bond CH dash CH double bond CH2. And this is also 1 2 3 4 H 2 3 4 5 6. Sorry, this is C4H6. Extremely sorry, C4H6. This is also C4H6. Right? It will be buta 1 3 diene, right? And you can say this also is the same thing. This is cyclobutene. This is also C4H2456. C4H6. So it is but1-ine, buta-1,3-diene, and cyclobutene. I think so. All these three types of isomerism we have understood now. So today I will finish only till here. I hope the three isomerism along with the previous one you have understood. So we have only one isomerism left, which happens to be tautomerism in the case of structural isomerism. Tautomerism I will do it in the next lecture. I hope you have understood. Just go through this lecture 8 coupled along with the previous lectures 7. So you will be able to understand it. You like that many more examples you will get. Right? I hope you have understood it. Just make a revision of each and everything. Okay? I'll take a leave now. Thank you. Thanks a lot. Namaskar.